Greetings, grade 12s, and welcome to Butu Academy Lessons That Empower. Welcome to our special series of exam preparations. Today, we are going to be looking at part one of the examination preparations for the Gauteng learners in grade 12, who will be writing the June examinations on the 15th. That will be paper one, and paper two on the 19th. So this video is dedicated to those who will be writing on the 15th, or any other person who has not yet written physical sciences who will be writing later than the 15th and the 19th, or also on the 15th and the 19th. Okay, so part one of this series will be looking at Newton's laws. That would be on paper one, as according to our scope. If you look at our scope, you will see there paper one, which will be written on the 15th as indicated on our scope. So that paper one will be made up of the topics that you see there, and first amongst them would be Newton's laws, as we can see, Newton's laws of motion. That will be what we will be looking at today. All right. What is it that we should expect in question two? It's most likely going to be question two. This topic will be featured in question two, depending on the structure of the question paper. Right, what is it that we should expect in this particular topic? The first thing that we have to expect are the definitions. It goes without saying that we are going to be asked to define one of the following. Either it's the normal force, the frictional force, or to state Newton's first law, Newton's second law, Newton's third law, or Newton's law of universal gravitation. Remember, it can only be one of the six definitions that I've indicated here, or two of them, depending on the structure of the question paper. Of course, it might be that there would be also Newton's law of universal gravitation, which we have to be able to state if asked. And please also bear in mind that we use the exam guidelines. Please do not use the textbooks to define any of these definitions. When asked to state a law or to write down any definition, please do not use your textbook. Use the exam guideline, because sometimes the definition in the textbook will differ slightly with the exam guidelines. And in terms of the guidelines, we are now using the 2021 exam guidelines. Of course, there was an exam guideline in 2014. There was one also in 2017, but now we are using the 2021. There were a few changes made to the 2017 exam guidelines. So try to use to get yourself a copy of the 2021 exam guideline and use those definitions there. Please make sure that you do not miss any of the definitions. You have to know all of them, because you don't know which one is going to be asked. Okay, so make sure that you get all your definitions correct. That is how you start passing the paper. If you start getting the definitions wrong, chances are you are not going to do well in your question paper. The second thing that we are definitely going to be asked is to draw a free body diagram. Now, I will say this to those of you who are new to our channel, to our videos. Please, if you still do not understand this part of the topic or this topic in its entirety, go to our YouTube page, look for the lessons on Newton's laws. We've covered this topic extensively. We've looked at the free body diagrams, we've looked at some calculations, and we've also looked at the different kinds of forces. So you need to know all of these things to master this particular topic. So you are more than welcome to go to our YouTube channel, Butu Academy, look at those videos and try and understand the concept, because here we are just going to be revising the stuff that we already know. So with regards to the free body diagrams, it can range from 2 marks to 5 marks, depending on the structure of the question paper once again. So we have to make sure that we collect those marks. All right, so you must be able to draw accurate free body diagrams. If your free body diagram is incorrect, it's going to affect other questions that are going to follow. So make sure that you master the drawing of the free body diagram. And I emphasize that if you're still struggling with this part, you make sure that you watch the videos that we've made before. Okay, practice as many diagrams as possible. Do not memorize them, practice them, because every diagram, every question has a unique diagram, and sometimes the information is different from similar scenarios. So you have to make sure that you understand what you are doing when you draw the free body diagram. Do not memorize them, okay? I have put a couple of them here. I want us to just revise a few things that we know about drawing free body diagrams. Now, let's say you were given a free body, an object, two objects like this in a system like this one, and you are requested to draw a free body diagram. Let's start with the easy one. The easier one would be the 3 kilogram block. If they ask you to draw a free body diagram for the 3 kilogram block, the first thing that we need to remember is that when we draw a free body diagram, we do not draw the object itself. We draw a dot to represent the object. In this one, there are two forces acting on this object, and there will be 2 marks. This would be a question that is allocated 2 marks. And the other thing we need to note about free body diagrams is that when they ask you to draw a free body diagram, you look on the right side of your margin of the question paper, you'll see 4 marks. You should expect to draw 4 forces, 1 mark for every force. So in this case, you'll be allocated 2 marks to draw a free body diagram for the 3 kilogram block. And the first force would be the force of gravity, or what we sometimes refer to as the weight. And the other force would be the tension. Very, very common that we come across scripts of learners messing up this force. Many learners would label that force as normal force. Unfortunately, because the 3 kilogram block is not in contact with any surface, there is no normal force acting on the 3 kilogram block. The 2 forces acting there are the weight, which is the force of gravity pulling the object down, and the second one is the tension because of the rope or the string that is attached to the object. Now, let's move to now block P to see what the free body diagram would look like for block P. Now, in this case, we are going to make an assumption that this surface is a rough surface because we don't have enough information. Let's assume that this is a rough surface. And if that is the case, now we look at block P and we try to see what is actually happening to block P. We will then draw a dot to represent block P. And then we can see that tension, or the rope, is pulling block P to the right. That would be tension. The next force will be the force of gravity, which is pulling it down, or the weight. And because block P is in contact with a surface, and a rough surface for that matter, then we have a normal force which is applied by the surface on block P. And because this is a rough surface, assuming that the direction of motion is in this way or to the right, if the motion is to the right, the frictional force, which always opposes the motion, will be to the left. Then that would be your kinetic friction. Okay, so this one would be a 4 marks question. A 4 marks question. The 4 marks will be allocated to drawing the free body diagram of all the forces acting on block P. Right, now let's move to the next one. Unfortunately, I'll have to cancel, to delete the free body diagram for block P. Okay, if you still need to study that, you can just rewind or take a screenshot and look at it again. Right, now here is another object which is on a rough surface. As you can see, the surface is drawn in such a way that it looks rough. So if you were to be asked to draw a free body diagram for an object like this one, you would once again draw the object as a dot, and indeed there will be a force of gravity, which is the weight. There will be a normal force because indeed the object is in contact with the surface, and the applied force is applied at an angle. Please allow me to remove this so that we can have a clear view of this one. Okay, the force applied is applied at an angle of 20 degrees. It's not exactly accurate, my free body diagram. And assuming that the direction of motion is to the right again, it means our frictional force, because this is a rough surface, the frictional force would be to the left, kinetic friction, if the object is moving. If the object is not moving, then the Fk there would be written as Fs for static friction. Right, now before I move further, I need to emphasize the issue of calculations versus just drawing a free body diagram. When it comes to the calculations, the force applied in this case would have to be resolved to its components, because it cannot be used as it is, since it is not in line with any other. It is not in line with the normal force. It is also not in line with the frictional force, and it is also not in line with the force of gravity. So it has to be resolved into forces that are in line with the other forces, because calculations require forces to be collinear or in line. Then we can add them or subtract them. So when it comes to the calculations, after drawing the free body diagram, you'd have to resolve that free body diagram in such a way that there is a force in the x direction, which is called Fx, due to this force. Okay, this is the x component of that force, and there would also be an Fy here, which is the y component of the force applied. Of course, there is a formula attached to this, and that says it is equals to F multiplied by cos theta, and this theta is that angle over there, the 20 degrees that has been given to us. Of course, indeed, there is also a formula for Fy, which says Fy is equals to F multiplied by sine theta. Again, the theta is the 20 degrees, which is the angle between the force and the horizontal line. All right, that is for the blue markings on my screen right now. The blue writing on my screen right now represents the resolution of F into the horizontal and the vertical component. We only do this when we need to do calculations, but if they only asked you to calculate, to draw the free body diagram, there is no need for all these blue forces and their calculations. There is no need for that. It's only there if they ask you to do some calculations. Okay, so the free body diagram would still look like this if you are asked to draw a free body diagram, right? Lastly, in the free body diagrams, let's say you have a free body diagram required of you for the 8 kilogram block or the 4 kilogram block. Let's start with the 8 kilogram block. Okay, in this case, you have two objects which are linked by a string, and both of them are in contact with different surfaces. Okay, this one is in contact with a flat surface, a flat horizontal surface. It's quite easy to draw the free body diagram for the 8 kilogram block. In this case, again, remember, we put a dot to represent the object. There is the normal force, there's a force of gravity, which is the weight, and there's tension. Tension is pulling this one to the right. And assuming that, here I'm making an assumption that the motion, the direction of motion is down the slope. Okay, if the direction of motion is down the slope, then the frictional force will be to the left if the object is moving. Okay, if the object is moving to or down the slope or to the right, the 8 kilogram block will be moving to the right, so that the 4 kilogram block will slide down the slope, and therefore the frictional force will always oppose the direction of motion, and in this case it will be to the left. Right, that's another 4 marks in terms of the free body diagram if they asked you to draw a free body diagram for the 8 kilogram block. Now let's look at the 4 kilogram block now. If they ask us to draw a free body diagram representing all the forces acting on the 4 kilogram block, it's a different free body diagram altogether. This one, it's one that we've discussed again in our previous lessons on the drawing of free body diagrams of objects that are in contact with a surface that is at an angle with the horizontal, or what we call an inclined surface. This is an inclined surface, as you can see, because it makes a 40-degree angle with the horizontal line of your book. So I've said before, maybe I should start with that. I've said before, when you draw, when you are drawing a free body diagram for an object which is in contact with an inclined surface, I would really advise that you first draw the surface. Please note that the surface is not one of the forces, it's just the surface. It is there to guide you to draw an accurate free body diagram. Okay, when that happens, After you've drawn the blue line, the blue broken line on my screen represents the surface. Okay, so then I come and draw. You can do that with the pencil, the blue line with the pencil. There's my surface, and there's my object. Now, remember, I prefer starting with the forces that are always going to the same direction regardless of the surface. The first force that is always in the same direction would be the force of gravity. It does not matter whether the surface is orientated at an angle or it's a horizontal surface. The force of gravity will always point downwards or perpendicular to the lines of your book or down towards the script, the bottom of your script, all the time. That would be your force of gravity. You saw with all the forces that we've drawn so far, the forces of gravity that we've drawn so far, all of them are pointing downwards. Here's one that is pointing downwards. Here's another one. That one also is pointing downwards towards the bottom of your script. Okay. Now the second force, which is mostly gotten incorrect by learners, is the normal force, and that is because now we have a surface which is not horizontal. All right, so now learners tend to draw a normal force which is vertical even when the slope or the surface is not horizontal. Remember, the normal force must always be perpendicular to the surface. So the surface is the blue line that we've drawn over there. Therefore, the normal force must be perpendicular to the blue line. You see why the blue line is very important is for situations such as this one. So the normal force must be perpendicular to, look at that. You see, the normal force is perpendicular to the surface. Okay, that's the normal force. And now, because the object, remember, we've assumed that this system is the 4 kilogram block is sliding downwards, which means the 8 kilogram block is sliding to the right. The system is to the right and downwards. It means the frictional force which is acting on this, since this would be a rough surface, the frictional force acting on the 4 kilogram block would be up the slope, since the box itself is sliding down the slope. Remember, all the time frictional force is opposing the direction of motion. That would be the kinetic friction there. So this would be a 3-mark question in terms of the drawing of for all the forces acting on the 4 kilogram block. But remember, again, just like we did with the 50 kilogram block on the bottom left of our screen, there are calculations that might be requested of you, in which, because of the force of gravity not being in line with the frictional force and the normal force, you would then have to resolve this force of gravity into its components. Again, this is a topic we've covered intensively in one of our previous lessons. Okay, let's look at this one. In terms of calculations, you would then have to break down the force of gravity or the weight into its components. It has 2 components. The first one would be down the slope, and that would be what we call FG parallel. And the second one is what we call FG perpendicular. That would be FG perpendicular, which is perpendicular to the slope. That we only do when we need to do calculations. So you don't have to draw the blue forces that I've just indicated now in your free body diagram. If you are asked to draw the free body diagram, you only do so when you are asked to do calculations. Then you have to resolve the weight or the force of gravity into its components. The forces are only drawn if you are doing calculations. So if there's no need for calculations, you are just drawing a free body diagram, it will be a 3 marks question. You don't have to draw FG parallel and FG perpendicular. Now we move to the third part of our topic, which will be covered in the exam. And that is the part that many of you look forward to, and that's the calculations. But before we go into the calculations, I want to emphasize that you cannot pass on calculations alone. I know many learners tend to focus and spend so much of their energy and time on the calculations. But if you check what we've done so far, we've done definitions and we've also done the free body diagram. That can give you a maximum of 7 marks, depending on the structure of the question. It can range from anything up to 7 marks. If you get the definition correct for 2 marks and you get a free body diagram of, let's say, 5 marks, then you have 7 marks before you do any calculations. So you need to take care of the simpler questions first. These are the questions that we call the low hanging fruits. So when you are going to harvest, you start with the low hanging fruits before you attempt the ones that are far from you or the difficult ones. So the calculations come after you've already covered the definition and the free body diagram. Now, in terms of calculations, the most common formula that we see a lot is the Newton's second law formula, which says F net is equals to MA. That's a formula that we're definitely going to see in our calculations, okay? But you should be able to determine the equation for this particular F net from the free body diagram. You see why it is important to get an accurate free body diagram? It's because it also dictates for you in terms of calculations. If your free body diagram is incorrect, your calculations are likely to be incorrect as well. All right, so you should be able to do the equation for F net, but also remember that F net is not necessarily a force. It is a combination of forces. It is the sum of forces acting along the same line. So you should be able to determine the equation for F net in order for your calculations to be correct and accurate. Now let's look at this example that we saw earlier on. Let us say you need to calculate F net for this particular diagram. Again, remember we did indicate that this is a rough surface. This is an object which is pulled by a force F across a rough surface. If that's the case and you need to do calculations based on F net, if you are asked to do calculations that require the usage of F net for this particular object, you have to remember that, like we did in the previous slide, we indicated that the forces acting on these objects this F can be resolved into its components, and that would be Fx and Fy. Why we do this? We do this for all calculations so that we can have the component of F, which is parallel to the motion, and the other one which is vertical or perpendicular to the motion. So in this case, I'm only going to indicate the forces acting along the line of motion. Okay, the forces acting along the line of motion here would be Fx, which is the x component of F, together with the frictional force, because this is a rough surface. All right, now to determine an equation or a formula for F net, now I can see that the sum of the forces would be F net is equals to Fx plus frictional force. Okay, the frictional force, which is Fk. Okay, my drawings are terrible now. Fk. Okay, this is the sum of all the forces acting along the line of motion. The line of motion is after the assumption that the object is moving to the right. If the object is moving to the right, it means it's moving in the horizontal dimension. Therefore, the forces responsible for that motion are the frictional force and the x component of F. So to get F net, we use this formula. So this is about the second bullet point. You must be able to determine the equation for F net in order for your calculations to be correct. Okay, excuse that. Now let us say I have to remove this for the next diagram. Let us say now you need to calculate for an object, for two objects which are connected via a string and they are both in contact with an inclined surface. Now I'm only going to do for which one should we choose? Let's choose the 1 kilogram one, because it has more forces than the 2 kilogram one. Okay, if I need to calculate, I need to be able to determine the equation for F net based on the 1 kilogram object. Again, I have to focus on all the forces acting on the 1 kilogram block along the line of motion, assuming that the object is moving up the slope or is moving up the slope. If this is the direction of motion, then the free body diagram that I'm going to focus on, I'm not going to focus on the vertical forces or on the perpendicular forces. I'm only going to focus on the forces that are acting along the line of motion. There is the 30 newtons force, or we can call it the force applied. What else do I know? I know that because this object is in contact or is attached to a string, there will be a tension force which is acting down the slope, because tension is a pulling force. It will be pulling it down the slope. And I know also that there is this is a rough surface. There's also going to be kinetic friction. But the other thing that I need to also think about is the fact that this object has a mass, and therefore there is a force of gravity. Let me just fix my forces so that I can be able to draw all of them. Okay, let's say this is the frictional force, kinetic friction, and then there's also the FG parallel. Now, if you focus on all the forces acting along the line of motion, F net being the sum of those forces, will therefore be represented by the mathematical equation that says F net is equals to F, as we can see, okay, my drawing, okay, is equals to F plus FG parallel plus Fk, which is the kinetic friction, plus the tension. Those are the three forces acting down the slope. Now, remember, the reason why, I know that some of you will be thinking, why don't I put a negative sign instead of a positive sign after the first force? Remember, the force, the F net is a sum. In mathematics, a sum is represented by addition, not subtraction. Subtraction is used when we are dealing with a difference. Okay, so here, because we're dealing with a sum, we add all the forces. Of course, you then have to choose, because these are vectors, you then have to choose for yourself which side do you choose as a positive direction. Okay, which means if you choose up the slope as positive, it would then mean down the slope is negative. In your next line, you are now going to substitute based on what you know as positive and what you know as negative. Obviously, the force applied would be positive, but FG parallel, FK, and T will all be negative. But the first line, you must show that I understand that here I'm dealing with a sum. The sum must be addition, and in your substitution, you then have to indicate the negative and the positive based on which force is going in which direction. Remember, in vectors, the negative and the positive are only telling us the direction. Okay, now that is about calculations. You have to be able to master the free body diagram and focusing on the forces acting along the same line, so that you can be able to add forces acting along the same line, and be very careful of the forces that are acting on an object that is in contact with an inclined surface. Okay, now lastly, we are going to look at one of the questions that is the least answered question in this particular topic, and that is the calculation of tension. We've just touched on it in the previous slide, actually. This is a question that many learners tend to do very poor in, so we have to be able to master the strategy on how to deal with this particular question. Number one, I always say to learners, please follow the steps. This is not a very difficult question. It just requires you to follow some steps and have an understanding of simple mathematics. Okay, the first thing that I'm going to say to you, when you are asked to calculate the tension between two objects, draw a free body diagram for the forces acting along the line of motion. You don't have to draw a free body diagram for all the forces. You just draw the forces that are along the line of motion. If the motion is up the slope, the forces that are in line with the motion are up the slope and down the slope. You don't have to draw the perpendicular forces, okay? Or if the object is moving to the right or to the left, you only draw the forces that are acting to the right and to the left. You don't have to draw the forces that are going up and down. This is purely for calculation purposes, not when they ask you to draw the free body diagram. If you are doing calculations, you only focus on the forces that are acting along the line of motion, okay? Excuse that. Okay, next, you then use this information together with your free body diagram to determine the equation for T, which is the tension that they want you to calculate. Okay, so I'll show you what I'm talking about here. And then after you've determined the equations, because you are going to have two unknowns on both equations, you then use simultaneous equations, which is something you've learned from mathematics, to calculate the value of T. Okay, let us look at a simplified version of what I'm talking about here. Let us say you want to calculate the tension. There's tension here between the two objects. This is a tension between two objects. Our two objects are the 1 kilogram block and the 2 kilogram block. Let's start with the 2 kilogram block. If we focus on the forces acting along the line of motion, assuming that the line of motion is up the slope, what we then have for the 2 kilogram block will be the forces acting up the slope and down the slope. Only those forces are going to be important for the calculation of the tension. Okay, so now I'm going to indicate the dot to represent the 2 kilogram block. The first force acting up the slope is the tension, and that's the only force acting up the slope. But there are two forces that are acting down the slope. The first one will be Fg parallel, which is the component of the weight acting down the slope. Fg parallel. Remember, this Fg parallel is also equals to mg sine theta. It's something that I did not mention in the previous slides, but it's also important. The next one is the frictional force, because this is an object that is in contact with a rough surface. Therefore, there is a frictional force, kinetic friction. Okay, so I know that F net is equals to MA, but what do I know about F net? F net is actually the sum of those forces. Okay, so I'm going to simplify F net and say F net is equals to T plus Fg parallel plus Fk equals to MA. And this is very important because now you know the mass of the object. You're going to substitute the mass. You're going to substitute the acceleration if you know the acceleration. But chances are you don't know the acceleration, which becomes your second unknown. So your first unknown would be the T, and the other unknown would be the acceleration. And the other forces, you are likely going to be given enough information to figure them out. Okay, so that would be the formula. Then after your substitution, then this becomes your equation number 1. Number 2, we go to the 1 kilogram block. If we focus on the 1 kilogram block, what we then come up with is that, okay, here is the dot to represent the 1 kilogram block. It is pulled up by the 30 newtons force, which is F, I'm going to call it F, is equals to 30. But it is also pulled down the slope by various forces, just like the previous one. The first one would be the force of gravity, the Fg parallel. The second one, okay, the second one would be the tension. And then thirdly would be the frictional force, kinetic friction. So there are 3 forces pulling the 1 kilogram block down. But what do we know? Again, F net is equals to MA. I'm not going to write that F net is equals to MA. We know that. So I'm going to say F net is actually equals to F, which is equals to 30, plus T, plus Fg parallel, plus Fk is equals to MA. And from there, all I need to do is to substitute. But remember, you have to choose a positive direction. If you choose up the slope as positive, then every force that is acting down the slope, in this case, there are 3 of them. The force of gravity together with tension and friction are acting down the slope. So then you substitute. If you know the mass, we do know the mass is 1 kilogram. If you know the acceleration, you even substitute the acceleration. But most of the time, we don't know the acceleration. That is why we use a simultaneous equation. Then this becomes your equation 2 after you have substituted and you are left with tension and acceleration, which are unknown. Then you solve for T simultaneously, just like I indicated on bullet point number 3. These are some of the tips that I can give you to follow when you answer question 2 of your paper 1 on the 15th of June, which you will be writing. This is directed to the Gauteng learners who will be writing their paper 1 on the 15th and paper 2 on the 19th. And of course, also those who will be writing their June examinations soon, because others have already done so. This is also applicable to the grade 11 learners who have not written their examinations as well. I hope that you are able to understand the concepts that we've covered in the video. If you do not, make sure you watch it as many times as possible. Also, do contact us, whether you are watching this video on TikTok or you're watching it on YouTube or you are watching it on Facebook. Feel free to contact us at any time. We'll make time to answer your questions. All the best with your examinations. We will be doing another video. The next video we will be looking at vertical projectile motions, which is the second topic that will be covered. We'll cover all the topics, especially in paper 1. Okay, if we do have time, we'll also look at the topics on paper 2. That will be after the 15th. Okay, all the best with your examinations, and make sure you practice as many times as you can. Right.